Hello, everyone. Today we'll be highlighting a robotic greenhouse maintenance system. I'm Melissa Dunbar.
I'm Cadence Murphy.
I'm Melissa Carvalho.
And I'm Daniel Hidalgo.
This system is designed to be operated by the volunteers of food banks and food pantries across the U.S. Food banks face ongoing challenges in maintaining a reliable supply of fresh produce due to short shelf life, unpredictable donations, and limited volunteer resources. This project aims to design a semi-automated greenhouse support system that uses a coordinated team of small robots to manage watering, monitoring, and harvesting, ensuring a steady year-round source of fruits and vegetables to community food banks. Our proposed robots to manage this system.
I am Cadence and I created the Smart Irrigation and Control Robot. This is the CAD screenshot featuring my plot with the water device above it, a control panel, and the water barrel. This is the Tinkercad circuit screenshot. This is the flowchart screenshot.
Hi, once again, my name is Daniel, and I'm going to be introducing the produce quality and inspection robot. Here is a rough model. It depicts the cameras that will be monitoring different crops, as well as bulbs that give an indication of when produce is ready. And the control center is where it does all the magic. All right, here's a simplified Tinkercad circuit screenshot. Here's a simplified flowchart screenshot.
So I was responsible for the greenhouse environmental control robot. So here is the CAD screenshot of what it looks like. So within the actual greenhouse, it has all of the components. At the top is the solar radiation sensor to sense like the UV. Within it are the heat lamps, the fans, the sprinklers, and then there's also shades over the windows. And then you can kind of see inside the temperature and humidity sensors. So here's the Tinkercad circuit, and then here is the flow chart that's going to show how everything works.
The pest detection and control robot has four contra-rotating propellers to lift, hover, and forward thrust. A distance sensor is used to locate plants or objects while various cameras detect pests and fungus. Lastly, a spray nozzle is activated if the internal AI chip determines if treatment is needed. The Tinkercad screenshot, the flowchart.
Water pump connected to a tank of water. There's a hose that is connected to the top portion that has a motor that moves the spray nozzle back and forth while it scans each individual zone for its moisture with the detection on the bottom.
Here we have the produce inspection robot. It utilizes a bunch of different cameras alongside different columns and rows to monitor the plants. There it sends the signal to the control cabinet, which will determine if a crop is ripe or not. If a crop is ripe, it will light up one of the LEDs alongside the camera to notify an operator of where the plant is that needs to be picked.
So the environmental control robot is seen behind all of the other robots. If you flip it around, right there on the top, you can see we have our UV sensor there that's going to send signals to the window shades and also to the sprinklers and the heat lamps, which if you flip the robot around again, you will see on the other side there, we have our fans along the ceiling, we have our sprinklers in between those fans, and we have these 6 heat lamps. And as you can see along the wall there, we have our temperature and humidity sensor, which are also going to be sending signals to those fans and to those sprinklers and heat lamps.
Using the propellers and distance sensor, the pest detection robot will fly around the greenhouse inspecting all the different areas. It can hover, it can raise, and move around.
Here was some simple benchmarking comparing our greenhouse to other greenhouse systems.
So our robot system will alleviate the burden of upkeep within a greenhouse and allow for food banks to have easy and consistent access to fresh produce. The amount of work our system will save will be able to guarantee families in need the nutrients they would not be able to easily get otherwise.
This automated greenhouse system was carefully collaborated on by the troublemakers to create a team of robots that help serve our communities and the people in it, and empowers food banks with dependable, high-quality produce while preserving critical resources.